Sometimes when you're writing a Lewis structure, you can write more than one good one. Let's look at SO2. So SO2, this is where we can look at symmetry. There's different ways to arrange one S and two O's. But most of these molecules tend to be symmetrical. So we're going to put the sulfur in the middle and an oxygen on each side. Each sulfur has 6 valence electrons, and each oxygen has 6 as well. So that gives us a total of 18 electrons to mess around with. So we're going to put bonds in there, a pair between each. That's 2, 4, 6, 8, 10, 12, 14, 16, 18. What do we need to do? Is everybody happy? One oxygen's not happy. So sulfur, who's next to him, has got 8 electrons, and so he's going to have to pitch in and share more with oxygen so this oxygen can be okay. So he's going to take this pair of electrons and share it. And when he does that, he still has 8 electrons. We had 2, 4, 6, 8. But now the oxygen also has 8. So this oxygen has a double bond, and this oxygen has a single bond. We can also draw it with the other oxygen having the single bond. They're both oxygens. How do we decide which one gets the double bond? They're equivalent. They're both equally good. They're equally correct. And so these are called resonance structures. And what happens is, not that we have 2 different molecules and that the double bond is like switching back and forth or anything, but what happens is that it's actually sort of a hybrid. To indicate resonance structures, we draw a double-headed arrow between them to show that these are equivalent structures. And what we find in reality is that we've got, it's kind of like a bond and a half between each of them. That these 2 bonds are actually equivalent. That was not a good way to draw it. If I make 3 dashes on one, I should make 3 on the other. So they're actually equivalent, but the Lewis theory doesn't give us a way to draw this. And so it's not a perfect theory. It doesn't explain everything. But the way we indicate this is we show both of the structures that are possible with a double-headed arrow. Sometimes there are 3 or 4 or even more possible resonance structures. And you're going to see resonance structures when you have at least 1 double bond, and we've got 2 atoms here that are the same. And if we had 3 different oxygens, then we could have 3 resonance structures. Give this double bond to first, and the second one, and then to the third, and we get 3 different structures. Either one of those Lewis structures would predict that we've got 2 different kinds of bonds in that SO2 molecule. But actually we find that they're equivalent. They have the same strength and the same length as each other, and the strength and length is between a double and a single bond. So you can kind of think of it as a bond and a half. But that doesn't work in terms of sharing electrons. So those are the resonance structures. We draw the double-headed arrow, and we recognize the true structure is like a hybrid or an intermediate between them. It's like if you took a dachshund and a Labrador dog, and they had puppies. What would the puppies look like? Well, they'd be kind of a combination of the parents, right? But you wouldn't have puppies that are going back and forth between looking like a Labrador and a Dachshund, right? They would always look the same, but they wouldn't look like either of their parents. Not exactly. And so the true structure here, it's like this is the mom and that's the dad, and the actual thing is in between. It's a hybrid, it's an average, a combination of those two. Write the Lewis structure for the NO2 minus ion include resonance structures. Well, we'll put the nitrogen in the middle and the oxygens on each side. 2 oxygens, they each have 6 valence electrons. The nitrogen has 5. The negative charge tells us we have to add an electron, and we're going to end up with 18 electrons. I'm doing it a little fast because I'm hoping to get through the section before the computer dies. So we have to put a bond in there. So there's 4 electrons accounted for. 6, 8, 10, 12, 14, 16, 18. You just kind of start throwing them around in pairs until you run out. So I ran out. Nitrogen isn't happy. So nitrogen tells this oxygen, hey, you gotta share more with me. So this oxygen says, oh, okay. So he's going to share 2 of his electrons. No, that's not what I wanted to do. I wanted to put them in here. So those go away. And then we would have a bracket and a negative charge, because it's an ion. Then this oxygen's thinking about it and saying, hey, why did I have to share? Why didn't the other oxygen share? He could have done it. Why me? Well, let's draw that too. Can you see how these are very, very similar? But there are 2 different oxygen atoms. And just like twins that may look alike, are they the same person? No, they're not. They care if you give one a cookie and you don't give the other one a cookie, right? So this one is not happy about sharing, and so this one now would not be happy about sharing. And so neither of these is great because it's not equal. It's not fair. But this is the best way we can draw these. These are the 2 resonance structures. And to indicate that, we put that double-headed arrow in between. The actual structure is intermediate between. Any questions?